What is the EigenNET project? Before we go to that, I would like to ask you if you have ever wondered, or perhaps even been annoyed, that a huge framework such TensorFlow has to be installed in order to train a deep learning structure. I will be completely honest. I often found myself frustrated when I'm setting up a TensorFlow environment with the right Python and TensorFlow version. What's more, I was always very happy when this environment remained stable and I didn't need to update. If you can rely on this, the EigenNET project might be right for you. This video introduces the compact and highly efficient C++ program DenseNN, which was developed as a part of the EigenNET project. What is DenseNN? DenseNN is a compact, powerful C++ program for the efficient implementation and training of dense networks without the need for typical giant frameworks such as TensorFlow or PyTorch. Instead, it relies on the lean and precise Eigen library to perform linear algebra operations at lightning speed and with minimal memory usage. The EigenNET project demonstrates how modern neural networks can be trained efficiently even in resource-constrained environments, ideal for embedded systems, scientific prototypes, or simply for anyone who loves C++ and wants or needs to avoid unnecessary overhead. I would like to mention just a few features of DenseNN here. DenseNN network architecture with adjustable depth and activation function, Eigen-based matrix operation for maximum speed, minimal code footprint, maximum control, ideal for demonstration, teaching and research. However, we know that it takes more than just highly effective machine learning to create a deep learning structure. DenseNN is integrated into frameworks such R or Python, and tasks such as data preparation or subsequent network analysis are handled by R, for example. All with a view of using the right tool for the job. But I think it's time for demonstrating, and you can find more information on the GitHub page listed below. Before we look at integration DenseNN into an R script, let's clarify where you can get DenseNN. Of course, this is not difficult. You can download DenseNN as an installation file from the GitHub repository Suprenum EigenNET via DenseNN. The EigenNET repository is the collection point for additional C++ programs related to machine learning, and the DenseNN repository is the direct route to DenseNN. To download the Windows installation file, you can go to Release or Installation Files. Going through installation files is a simpler option. If you would like to modify DenseNN to match your requirements, you will find all necessary C++ files in the SCR directory. You can find the R script shown in a few minutes here. A lean, clear documentation is provided in the README section. Now let us turn to the R script. These are the three current R scripts from the DenseNN repository. The Dens example script shows the necessary steps for the data preparation, then calls the C++ program DenseNN-exe, and the script training progress visualize the progress of the network training. The scale feature script contains a scaling function for the features. Before we take a closer look to the R scripts, we need to turn our attention to the file area. You can see that DenseNN was installed in the calling CNN directory. We switch to the binary directory, where DenseNN-exe and the sample data are located. Please forgive me for having already done some primary work with regard to the sample data. However, it makes it easier to execute the script if this directory is set as the R working directory. a simple test to check whether dense_nn and the R working directory are installed correctly. It is to call up the dense_nn help function. Okay, everything seems to be correct. The argument list and the simple application example are displayed on the R console. I assume that you are a little familiar with R and its essential functions, so I will now go into details. First, I load the necessary packages and the function for scaling the features. This is followed by the script section for preparing the data and in particular providing the expected data structure for dense_nn. The label must always be the first column in the dataset as shown here. The execution of the script section takes a few seconds. After that, the processed data is saved as a CSV file under the name shown here. The test data is processed in the same way, but this is not shown here. Now we come to training the neuronal network. The MNIST dataset, which is often used as a test dataset, is used here as an example. We only need the labeling part for the later graphics, and the arguments for calling dense_nn are essential. Mode 1 means that a deep learning network is trained with the list arguments. I think you are familiar with the arguments from other ML environments. Let's start the training. And first we will see the output of some information about the dataset and the number of network parameters. And then every 10th epoch information about the network training. The training is terminated before reaching the 150th epoch using the early stopping method, controlled by min delta 0.001. The training quality looks quite good, but let's take a look at the training logbook. For graphical visualization, we execute the R script display training progress. Let's first look at the training process in terms of correct classification and loss functions, and then the weights after training for the layers. The graphical output can be used to tune the network. Of course, this is just one example of a workflow, and you will surely think of other possibilities. Let's go back to the dense example script to test the network with the test data. Only two arguments are needed to perform the test: the test mode 2 and the test dataset. We display the test result using the script section and are shown various overviews of the classifications. For example, it shows that some numbers are difficult to classify. What we have seen so far is a classification model. Of course, dense_nn can also learn regression models. This is described in the script section regression model. I will also create a video on this later, but I think that the script is readable and executable for R users who are not completely inexperienced. This should be enough for the first dense introduction video, and I would like to be delighted if you show interest in this project. I welcome any suggestions and contributions. Bye for now.